For this cycle, we've, or I should say really, Travis has undertaken the task of adding OpenGL ES support to Compiz and also to the Nux library that's used to implement Unity on Ubuntu. And that work is still ongoing. The Compiz work itself is largely done. There's some additional plugin work for plugins that aren't used directly to support Unity, and some bug fixing that's ongoing in the background while we're here. And then the Nux work is proceeding again as we speak, at least while Travis and Alexandros are not in session. And the expectation there is that that stuff will be done end of this month. So, with all of that in mind, we'd like to talk a little bit about things to do for the next cycle. There are some obvious things. The work that's been done hasn't been pushed up into the master for Compiz yet, for example. So I would suggest that that's probably one thing that's worth talking about. At least making sure that we have a good plan for that. And I think beyond that, to say the additional plugins that aren't currently supported, maybe it's best to list those. Does anybody, do you have your list handy?
Well, the
Can get it for you.
That's fine. I just want to make sure that we note that as, you know, part of the outcome of this session is that, you know, that we've identified the plugins that we know that are left to handle, and that.
Okay, I'll post the link.
It's fine. Yeah. It doesn't. I know. I just asked, you know, Ricardo, because you sent it out before.
Don't worry.
So beyond that. I know that from talking to Jay, it sounds like there's going to be some additional work on Nux that may intersect with some of the stuff that we're doing as well. So I guess I'd maybe like to start off by saying, is there anything that we think that we want to do in terms of cleanup? Are there shortcuts that we took to get where we got as fast as possible that maybe we should think about cleaner ways to solve, that kind of thing?
Well, I mean, in the main Compiz core, the OpenGL plugin, there are a few spots where it's basically 1,000 line of code, if-def, and then another 1,000 line of code. If you're on GLES, it'd be nice to have that a little more organized.
That sounds like a good candidate.
Otherwise, for the most part, it's been pretty clean and plugins.
Okay. There were a couple of work items that we postponed from this cycle, and I think at least one of the ideas that I had around those was those would be a good seed for this discussion. So pardon me a moment here on the screen while I pull those up.
I pasted the link from my email.
Okay.
And that link is actually not quite where we're at, but
Yeah, no, but
yeah.
give an overview.
All right. So, and some of these are my enumeration and not so much Travis's, so feel free to correct me if what I'm about to paste is no longer valid.
Yeah, the one for Cube and Wobbly, that's not really what needs to be done, but that was a good overview of the general idea.
Okay. What about the shader API for the OpenGL plugin? Is that part of what you meant by the if-def stuff that you wanted to rework?
No. Right now, there's no way for plugins to do their own shaders. Like, so the blur plugin needs it. For example, the color filter for color blindness support, and then due to some of the changes, Expo will actually need it for the non-default mode. Like there's an option to have it like curve all of the desktops when you view them. That will need to be done in a shader now.
Okay, so it sounds like that one, if nothing else, I'm gonna go ahead and then take this one.
Yeah, that one's just a
and
straightforward optimization.
Yeah, exactly. So it sounds to me like, if nothing else, we are actually even able to build a little bit of a dependency graph based on this. So, okay, so you said that, I'm sorry, blur and what was the other one that will basically depend on the shader API being there?
Well, blur is the only one that Unity uses that will need the shader API. Expo, if you want to change from the default settings, will need it. And then there's things like the motion blur plugin, color filter. I think there's a couple more, but I always forget someone to make a list.
Okay, so okay. And so, and Cube and Wobbly are plugins that just you haven't actually attacked yet because those were some of the ones. Well, I'm just looking at
right. Well, Cube uses display lists to manage the Sky Dome background image, like you have like a wallpaper behind the cube. It's really not that much to do. I just have to pull out what it's putting in there, and
okay.
Otherwise, I can always just disable the Sky Dome for now if we really need it quick. Wobbly does its own geometry generation. And the code it uses to do that has basically always just been copy and pasted around to all the plugins that need to do something similar.
Okay.
It's some pretty hairy stuff.
So is that something that maybe warrants separating out into something common, or does it?
Well, I think there's only 2 places that use it.
Okay. Okay.
And it should get much simpler with the new setup. So.
Okay.
It's just a matter of pulling out what exactly it's doing now to put it over the new setup. I spent about an hour looking at it and decided it wasn't important for now.
Okay. So let's see, what else do we have? Seems like a fairly good start. Anything else that struck you along the way? I mean,
well, I mean, nothing as far as unique problems to the GLES stuff.
okay.
There are lots of cases where you can't combine effects because they all like clear out the existing window geometry and generate their own. That the per plugin shader stuff should help with. They can just modify the existing stuff instead. But that's not really a new problem.
Sure.
Are there any problems with drivers in Wobble? Or specific drivers? I mean, we have only OMA for IMX at the moment. Perhaps it would be good to have an action to try it everywhere we can.
Yeah.
When it's done, so we can see the drivers are missing something, or something we do is that.
There were actually apparently some problems with Tegra too. I guess somebody got it working with Ubuntu. It's the exact same kind of problem that Sam gets on his Nouveau setup on his laptop though, so I don't know if that's something with the card and what I'm doing, or do they both do the driver the same way, or what, but that we'll have to get sorted out, I guess. Otherwise, on the OMAP 4, it works okay. On the IMX 5.1, not yet, but I think that's just something I'm doing wrong in the setup.
We might have a chance to try it on I think things are proceeding pretty well with getting the binary redistribution agreement from ARM through STE and Samsung. So we may, not long after everything lands, we may have a chance to try it out on Mali as well. So that'd be another good data point. As far as the NVIDIA stuff, it would certainly be good to understand it. If it's something that generally affects Compiz, that's even better in the sense that it just makes it more flexible for getting worked on.
Yeah.
But yeah, it might be good to keep track of stuff that we know is not quite right with it on certain platforms. I mean, I think there's some things that we know about the IMX51 drivers that that we expect, and we see that for other applications as well. So that's not those aren't surprises, but yeah, certainly anything that we run into, we should definitely keep track of.
Is there a PPA that people can use to test?
Yeah. Are we using yours, or are we using the working group PPA for them?
No, at the moment it is mine, but
okay.
We can move it to the working group.
Okay, so if you look, there's Linaro minus graphics minus WG, and there's our working group has a PPA, and I suppose
I can push that if you need it. Just I don't need to.
I don't want to duplicate too much work, so if it's, I just thought for general public access, I thought it would be better for the working group, but if it's easier for you to maintain on yours, that's fine too.
No, I just need to have access to the working group PPA, and it should be
okay.
I can just push it there.
Yeah.
Instead.
Okay. So you guys keep that up, like fairly up to date.
It's as a
I'm wearing the Linaro t-shirt now.
So we have we have a schedule. I won't bore you with the location on the Linaro wiki, but we have a rough schedule for each of the components that we work on for how often we release it. Typically, it's something on the order of monthly. So it gets updated with that kind of frequency as far as having new stuff to try out.
Yep.
But there may be some, just be aware there may be some experimental stuff on there as guys are working on items. Sure. They may say, hey, can you try this out on on your platform or whatever, and you may see some experimental stuff in flight. But in general, that's we have a charter to keep those things pretty fresh, and for the components that we've been releasing, it's been on the order of about once a month. Typically, they're named for our internal milestones, which would be something like the release dates. So it'd be like 11.06 or something like that.
Yeah.
So okay, fair enough. Yeah, I can put it even a work item for me. I don't know to push the Compiz package on the working group PPA. Okay. Even through Alexander's, even myself.
No, we can get you added. I think the way that it worked is that I think it's just whoever's in the Linaro graphics working group.
Yeah, okay, just add it.
Yeah.
Okay, I'm not part of Linaro, so it should be easier.
Yeah. No, I'll take care of that. That's not a problem.
Can you push the BZR branch for that as well?
Yeah, we can.
Okay, that way.
The Nux branch, you mean?
No,
the packaging branch.
The packaging.
Oh, okay. So sure.
Then it's easier. I can just push the same group.
Okay.
Working group, so.
Okay.
Awesome.
Make that available for there. Currently, there's basically two packages: Compiz and Compiz plugins, man.
Yeah.
So.
Should have extra in there soon. But yeah.
Okay.
Do we have a timeline regarding when this is going to land upstream?
Yeah, that would be.
Pretty much, I think what me and Sam agreed on is once the shader stuff gets sorted out, and it seems like the API and everything is settled down. As long as we get the plugins that we care about ported, then it can get merged in, and any plugins that aren't done, like the unsupported ones and some of the ones in extras that nobody really uses or seems to care about, then if the community members want to port those because they use them, well, that's cool. Otherwise, it's not a big loss.
Okay, so you want the shader API plus the plugins that will use the shader API to be wrapped up, and then the idea is to push that. No, I'm fine with it. I just want to make sure that I understand it correctly.
Yeah, and I mean, not necessarily all the plugins that would need the shader API would be ported, just, basically just the ones that Unity uses, and then some that are, you know, that we know are popular and such, like Wobble has to be
Right.
done, Cube has to be done.
Okay, so,
It's,
Yeah, it would just be that, and then possibly add some kind of fallback story, or some kind of documentation on how community members can actually get started with porting the rest of the code. I mean, it's just a matter of, from what I understand, it's just a matter of replacing the fragment shaders and the inbuilt geometry system that's done in software with vertex shaders. It's not a particularly big deal. It's just something that, you know, just requires a bit of effort to do. So as long as we can get that documentation out there for people to actually be putting those plugins themselves, then I'm sure like it will be fine running everything else stream.
okay.
Yeah.
gonna have to write documentation.
Okay, so, okay, no, that's good. Okay, so you want, so Sam, what is it you want documented?
Just like a general guideline on, you know, how the old geometry system worked, because that was always ridiculously confusing. I'm sure Travis has probably worked it out by now, or is in the process of working it out.
More or less.
And also how the new shader, the new vertex shader interface is going to work.
Yeah,
And basically just a simple guide on like, okay, here's what you basically need to move across.
A porting guide, pretty much.
Yeah.
You know, we can, if nothing else, we can add that to, you know, we can probably add that to the wiki that we've got going as well.
Yeah.
And, because it's that kind of, well, okay, it's non-specific to Compiz, but that kind of thing is loosely covered in the little porting guide wiki that we've got going. So probably, if nothing else, be easy to yank something out of there and then add the description of the existing Compiz geometry model.
Well, I mean, in this case, it's probably going to be fairly Compiz specific. It's a matter of porting things from using GL window geometry class to GL vertex buffer class.
Oh, I see. Okay, so it's strongly with respect to internal API.
Yeah.
Of Compiz. Okay,
yeah.
I got it.
So probably the best place for it's on the Compiz wiki, along with all the documentation Sam wrote for writing plugins and such.
Yeah.
Okay. Anything else that we, Sam, anything else you want to add that you think we need before we're seriously in danger of sending out patches?
Not really that I can think of. I mean, the only like other nice to have that I can think of is just some kind of fallback story, but I doubt that, considering the way that like the OpenGL and OpenGL ES libraries kind of interact, that's very difficult to do.
Right.
So,
Yeah,
and a story that would be nice, but I understand that that's like ridiculously difficult to do as well.
Well, I mean, the OpenGL plugin will fall back to basically the old 1.1 plus extension system, but excuse me, the plugins still have to be ported to the new API and such.
All right.
As far as porting the plugins to the new API, I mean, all they really have to care about is if they use fragment programs now, they have to do a fragment shader, and everything that is called, you know, GL fragment in the code needs to be changed to GL window painted shrubs or whatever.
Yeah.
Otherwise, if we don't use them on GLES and nobody cares to port them, if they keep using desktop GL stuff, I don't see why they wouldn't work.
Okay, so you've actually kept the old geometry system for desktop GL.
No, it's just it's mostly hidden from you, unless you're overwriting, you know, like add window geometry or whatever it is. You know, unless you're overwriting the geometry handling, it's done for you in the behind the scenes.
Right.
So it doesn't matter that it's done the new way. You don't have to care.
Right. So add GL add geometry is still there. Is that what you're saying?
Yeah.
Okay.
It adds the geometry into the new stuff.
Okay, so it's basically just an implementation of that on top of the version stuff.
Yeah, the only thing that the plugins would have to worry about as far as changing their GL code would be getting rid of calls to enable and disable blend, because just left that on because everything immediately turns it on and then turns it off when it's done, so it didn't make much sense.
Alright, yeah.
Otherwise, if they only care about running it on the desktop, all they really have to do is port to the new API,
Okay.
which is almost automated. I mean, you can almost automate it. It's
The GeoBlend stuff is probably a different discussion. My understanding of that is that the plugins turn on and off because that's more of an optimization, even though it is very small. So
well, I mean, they don't ever do anything without turning it on first.
yeah.
So
Well, there's the case of if no plugin is doing anything, then you don't need it. Right? Yeah.
So are these build time options, or is it going to be dynamic at runtime?
Which?
Well, whether it's Compiz will use OpenGL or OpenGL ES.
So
How does that work?
currently it's build time and defaults to ES on ARM platforms and desktop GL on x86 platforms. We have another project in the group that at least until the desktop world is ready for EGL to completely drive the bus. We have another proxy library that will allow you to do runtime selection. It's maybe not quite ready for something as big as Compiz, but that is definitely in our, looking slightly more forward plans.
Yep.
But again, some of that will depend on whether some of that to me at least will depend on whether it makes more sense to converge on using EGL as the Windows system interface for everything, and just using bind API to do your runtime selection, which is clearly the cleaner way to go. But we don't have that today. So for some of the other things that we've been working on porting, in order to be able to do runtime selection, we've done this proxy library. So that it is possible. I'll have to take another look at the OpenGL roadmap and see where it seems like that's going to fall.
it's not quite like that. If you have the headers for GLES, it uses that. So right now there's no way to turn it on and off. If you have the headers, then even on the desktop it'll compile the GLES version.
Is that predicated on the build system, or is that?
Yeah, it's just didn't figure out how to add an option specific to a plugin. So yeah.
So is that an issue for the greater build, so to speak?
Well,
I mean, if it's doing header detection and the ES headers are installed on the build system that you're using to build desktop, is that a problem?
they won't be, because we won't build depend on them.
Oh,
So
okay.
they won't be there.
Although that may confuse things for people that are trying to build it,
Yeah,
If the people on a desktop try to
ideally-
rebuild the package, then it would be broken, basically.
Yeah, I mean, ideally we would have a better solution, and I'll talk to Sam about, I guess, figuring
But
out
currently
how to tweak the
it's
build
basically
system.
checking for the GLS header first,
Yeah,
and then GL is now a kind of a fallback.
yeah.
Okay.
I could always just flip it around, but then I wouldn't be able to test it on my laptop.
But as for now, we can just fix that on the package level. We can just put the build
Yeah.
dependencies on depending on the type of the architecture they have, and then put it on the builder, and the builder will solve it for us.
Yeah.
I mean, it's fine with me, either way, but I am at least a little concerned that that we don't really mess things up for other folks.
people.
Yeah.
Yeah.
Okay, so okay, that's good to know. Is there a way to do it based on host or based on the target host?
If we made Compiz basically depend on dpackage, yeah. Otherwise,
It's hard.
Okay.
otherwise, doing the detection manually would be a bad idea.
I didn't actually hack a lot on CMake, but maybe you could just specify a build option to make it available with GL or GLES, and then
Yeah, I mean, I
it should be even
suppose-
better than just checking for the headers, because currently the best situation that I have is if you're using a desktop, and if you, for example, push this to the Git and try to build it to Git on your desktop, and for some reason you have the GLS dev package installed, then it will basically install for and compile for GLES. Is not going to work on your desktop. So.
Yeah, no, I mean, it's not meant to be the final way it works. I just have to go in and figure out how to add an option that the plugin can depend on.
CMake must be quite broken. I mean,
Well,
if
I think it's
so
pretty
hard,
straightforward,
yeah.
actually. I was just trying to do it like localized to the CMake files for the plugin, but I think I'm just going to have to add it to the global. Yeah.
Yeah, makes more sense.
And just have that set of variable, you know, a global variable that the plugin build can see.
So, okay, so in short, for now we can fix in the package, but later on it would be good to make it available as a build options for
Right.
CMake.
Okay. Yeah, that's. Here, I'll amend Alexandra's note there.
Another question. Do you see any opportunity for optimizations in Compiz for GLES or?
Well, assuming the same kind of code that would, you know, optimize it for GL would, for GLES, you know, in general, do as little as possible. We're probably okay there. The main thing that was lost with the conversion was we no longer interleave data, so you just have your vertex data and then your, you know, your color data separate.
So another thing that I was thinking about, and I guess I'll talk and type at the same time, is, and this has been kind of my pipe dream all along since Alexandros and I started talking about our, we have another sort of compositing benchmark utility that we've done. And one of the things that I think would be really, really cool to do there is basically to, you know, adapt the functionality from real compositors into the benchmark, which obviously does two things. One is it gives us more and better tests, more real world tests than the sort of synthetic ones that we've come up with so far. But it gives you the ability to have a history. So, you know, for version X of Compiz, for example, if you know that these plugins, for example, are implemented as tests in GL Compbench, then, you know, you change it and you can actually look and say, okay, here's what happened between versions X and Y, or you can say, what happens if I modify the shader for this plugin this way, and you can actually do some performance evaluations before you actually go to, you know, to commit something. So it makes for a really good, to me, it makes for a really good sandbox for doing that kind of thing. So it would be good to do it for all of them, but I would say to start with, pick 2 or maybe 3 interesting ones.
Yeah, the main core ones, basically.
Yeah, and you know, we should work on getting those ported into GL Compbench. Just like I said, it's a, you know, I think it's good. It's good across the board.
Yeah, I mean,
Yeah,
that
makes sense.
should be pretty straightforward. I mean, since they're all, everything's implemented as plugins, it's already pretty well spread out.
Yeah, that's, I mean, so the way that Compbench is set up is even the tests themselves are sort of like a plugin, right? So it's basically you're handed a list of windows that whose content you're going to composite, and you can do whatever you want. You get, you know, basically it's technically a shared context, but you basically get your own clean slate with whatever state you need, you know, whatever geometry state you need, whatever you know, buffer object state you need, that kind of stuff. So it's kind of, you really do kind of have your own sandbox within the bounds of that test, and just whenever there's an event update, you get called, and that's it. So it's pretty straightforward, and the way that it's done is really easy to create a new test, I think. So I think that would be really cool.
Okay.
Good dog fooding method.
Yeah, that should be nice. If nothing else, we can keep track of whether or not the drivers are slowing down on us.
Well, and that was the original part of the point. You know, when we talked about doing this, you know, I guess mostly in Dallas, that was something that really kind of came up mid-cycle. We didn't plan on this at last UDS, and that was it. You know, it's you know, the discussions we've been having around, well, how does this work on platform and whatever. this gives you the opportunity to do that without having to build all of Compiz or do anything else that you don't have resources for. Since all of us, we kind of have different hardware scattered throughout the group, so it makes it a good way to cover. So, anything else that we want to think about for Compiz? There are additional topics here that we wanted to cover a little bit during this session, but I don't want to, I don't want to derail the key pieces. So. And I think, by the way, as sort of a follow-on to the comp bench discussion and to the additional items that we've already captured about running Compiz itself on additional platforms, I think that will itself generate additional work items as well. We'll find opportunities for things that could be faster or could be cleaner or could be whatever. So I think we can definitely allow ourselves some amount of wiggle room as far as that goes. But if there's anything else that we know now, any other comments from the crowd, Compiz users that have nice to haves or anything like that? I mean, we can't promise everything, but
I guess the only thing that would be great is what would win you guys a lot of community support is if you could really show off the power of what you can do within your shader-based system. I mean, there's a lot that was very limiting with the old geometry system, where we had to do a lot of the transformation of software and it's very slow. If you ever do get time and you ever want to show off what you can do with the new geometry system, I think that would be great because you kind of tell people like, oh yeah, you'll be able to run Compiz on OngoingGL ES now, and they'll kind of just nod their head and go, oh, okay. So if you can really show it off, then
sure. And by the way, I guess you have to be a little careful about versioning.
Yeah.
There are some differences between GLSL and GLSL ES.
Yeah.
But those aside, and they're easy to account for. Though they, since you mentioned transformation, they do sort of relate to that because things like transpose and inverse functions on matrices don't exist in GLSL ES.
I don't think you use them.
It's fine. Again, they're not necessarily, again, they're not there because not everybody uses them. They're interesting for things like turning your model view matrix into a normal matrix.
Yeah.
But aside from that, you don't necessarily need them all over the place. But those things aside, GLSL and GLSL ES are pretty much identical. So it's, the shaders that you can do on ES, you can do on desktop GL as well. So it's, it'd be the kind of thing where, you should be able to have sort of a common base of shaders regardless. But yeah, I'm sure we can think about some effects that might help to do some new things.
Yeah. Have you got ideas for effects that you've been waiting to do?
I don't have any ideas, but it's just like if you can think of anything that that would, I guess, bring some like tangible value, I guess. Yeah. It's just like, of course, from my perspective, I understand like, oh yeah, ES support is actually a really big deal. But if you talk to a regular user, they'll kind of just give you a bit of a confused look. So, right. I mean, like, if the best way that I find to bring communities over is just to say like, okay, well, look, we've unlocked all this new functionality now. Right. Yeah.
Okay. Yeah, we can.
Just like, if you ever get time to do it. If you don't, it doesn't matter.
We will. One of the things that we try to do in general is plan out whatever we think of, and that way, even if we don't get to it, there's enough information there that somebody else can come in and pick it up.
Yeah.
So but certainly we'll put that down. So okay, so if there's nothing else that's Compiz specific per se, at the risk of getting ahead of ourselves, Nux?
Well, most of the things that are tricky to get working on GLES there, Jay has basically told me don't matter anyway. Just comment that part out basically. Okay. So that's coming along pretty nicely. I don't think there should be any huge issues at this point.
So Jay, is there some place that's documented what is being deprecated from Nux, or?
Not yet.
Okay. So if you have something like that, even if it's an informal list, it would be good to have that so we can document it as well. I know you mentioned that you have some plans for where Nux will go over the next cycle for you guys. So are there things that we should be aware of, so that, you know, either things that we need to account for, or, you know, maybe things that
in structure is going to remain kind of the same. The shader structure that we use. What we're going to do is more high quality effects for desktops.
Okay.
And so of course those shader will be marked as, okay, this cannot run on GLSL, on OngoingGL ES. So that, you know.
Are you sure it's not going to run? I mean, it's just, the GPU is very powerful, so.
Yes, it is very powerful, certainly. But, you know, as a precaution, you know, if I found that, oh, we're using this kind of instruction here that is only available in GLSL 3.0 or 4. You know,
right.
Something. Of course, we're going to mark those one as unavailable for OngoingGL ES. Other than that, the structure should remain pretty much the same. There's going to be some cleanup in the code. Some files are going to be removed in order to make things a bit easier. We're also looking for an improved way of loading images, you know, in the background. When we have a lot of images, you know, we want to create a separate thread to load them in memory and then make them into OngoingGL textures.
Okay.
I don't know if this will be affecting you somehow. Maybe.
I mean, it shouldn't in any obvious ways, at any rate. And it sounds like, you know, sort of general support more than, you know, this only matters in one particular area or one particular platform. So that's good. How about so as a follow-on to the talk about the Compiz plugins as comp bench tests, I don't see any reason why we couldn't create another test bed for Nux shader enhancements as well. So do you think that's more appropriate for GLMark, or?
Well, it depends. Well, yeah, in a sense, yes, because Nux doesn't have to do anything with Windows and stuff, and the whole infrastructure in Compiz.
Right. That's what I mean. And we have, I mean, the only thing that GLMark is limited for is models. We, you know, there's 3 models available that we can draw, but you could do whatever you want with those in terms of shaders. So that would actually maybe be kind of interesting, is to, you know, take one of the models, like, you know, the horse or whatever, and draw it with the default shaders that are part of the test now, and then switch over to some alternate shaders and see what the performance difference is. But yeah, I just think that's something, especially as you're talking about adding effects and you're concerned with the behavior of those on desktop versus embedded GPUs, we can certainly help evaluate that.
Right. The way we render in Unity, we pretty much everything is a quad, a rectangle that we draw on screen. So we have a lot of quad-based drawing functions.
Right.
That, for example, one quad, you know, a function to render a single color quad, a function to draw 2 textures on the quad at the same time, blend them together. So we have many of those. So I don't know, maybe that can be useful in the test configuration for you if you ever feel that's needed. But it's very easy to use. You just have to call the function.
Okay. That's an interesting turnaround on at least on the way I was thinking about it. But yeah, we could look into that. Yeah, though. So you're saying the API describes things in terms of quads as opposed to they're implemented as quads? At least for now.
Yes, we have an API. We have the rendering API for Unity is based on quads. So we have a special set of functions that can draw quads. Right? Sure.
No, I was making more of a comment on the quad primitive not existing in.
Oh, yeah, it's triangle.
Sure. No. Sorry, it's maybe a little too early for bad jokes. Okay, so.
I mean, we can talk more about this. We have 2 sessions. One is for.
Yeah, I'm mentioning this mostly so that we can defer those to these other sessions, because it's not necessarily appropriate here, but I do want to capture that. Because I do think it would be interesting, and again, you know, for us, you know, again, at the risk of getting a little off topic, for us, the more tests we have, you know, the more code that gets ported over to work on ARM platforms, the better idea we have of how things are really working.
By the way, we have a test directory, not, don't know if you've seen it, basic called GPU test.
Yeah.
A basic set of, you know, tests that, you know, draw quiet on the screen, and you know, I want to add more testing in there. And they're basically using Nuxt Graphics API to render some stuff on the screen.
Okay.
So when I get the chance, I believe these are the first steps that I will try and get working on my phone.
One question, do you have some kind of test suite for, I mean, you can, for conformance, so you can test, for example, if what we did with OngoingGL ES is correct? And,
conformance, are you talking about the result, the visual result?
yeah, the visual results of what would you expect your widgets to look like, for example?
No, we don't have a conformance test. Like for instance, let's say having a reference image of, you know, a picture of two textures blended together, doing the same thing with a Nuxt core that does that blend two textures together and try to see if both are correct.
Yeah.
We don't have those kind of tests.
So my question is, okay, so we're moving on with porting Nuxt, and how can we be sure what we have done is correct, apart from trying it, you know, live, and even then we may not sure what getting is correct because we don't know exactly what to expect.
Well, I think that for the set of functions that we use for rendering, we could, you know, I could, you know, say, okay, here's what it should look like, and give you an image and say, okay, I have, I'm rendering a color, okay, like a blue, okay, so I'll show you a blue quad, and you draw something and say, okay, so they match. Or you can compare them pixel by pixel. That means I will give you a texture that is the final result. And when you blend two textures, I say, okay, here's the texture A, texture B. I do the blending in some arbitrary tool like a GIMP. I blend them together and say, okay, this is what it should look like. And you know, you use the Nuxt function call and provide those two textures. They blend in on screen, and you get to see the difference. Something like that can be made for basic, you know, basic drawing code that we're using. You can even do that up to you know, even the blurring algorithm that we do on a quad, for instance. You give it a texture, you need to blur it. You can take the same texture, blur it in GIMP or Photoshop, and try to see how things go.
So for now, I think the best thing that we can do is just run on our desktop OpenGL,
Right.
and just, you know, have it.
Yes.
Make sure that we're
That
at least
also.
very close.
Okay, so so I think that's it for there, unless you guys have any other ideas. I wanted to spend at least some of the rest of the time that we have on. So one of the other things that we did this cycle was did, I guess, largely in the way of packaging work around kwin and even the Chromium Window Manager. And the Chromium Window Manager hasn't landed in the PPA yet. I don't think Tom's done with it yet. But kwin has, and we've even contributed some patches back to that based on the work that Jamie did this cycle. So we don't have any discrete work items currently planned, other than to continue to evaluate those and update those packages as new changes land. But are there? I know we have some remotely, but are there kwin users out there that have some ideas that things that based on GL ES support in the first place that they would like to see better on kwin?
There's definitely some optimization work needed there.
Okay.
There also are some packages that are still using OpenGL directly, not GL ES or anything, that don't work anymore since we ported the Qt OpenGL stack to be GLES on ARM. So there's still some porting work that needs to be done there to make sure that all the applications will work on ARM environments where GLES is now default.
Okay.
Yeah,
Scott Kitterman was working on that some, but
I guess most of the fixer fix it. What I saw is the glue. The glue, I think you were also working the CycleNet. Am I right?
Oh, the extension wrangler? Yeah.
So we should have that fixed over the cycle, because that was something that didn't have any kind of support for GLES.
Yeah, so Sharik did the work on that. Yeah.
Okay.
So, and that's, I think, is just about to go out for review. So we have the tree on git.linaro.org, and it would be good to also get that building in the PPA as well.
Okay, cool, because that was our main problematic package, because we had a lot of packages depending on it, and then it would basically break, and a lot of Qt packages depending on it, as a consequence of Linaro and other packages, so good to have it working. But most of the other issues, you kind of have it fixed already. So then it's good to have it by default now, because then the Ubuntu guys can just basically try it
One
on
question, the Wrangler, is it smart enough to do mapping from functions that are in GL, or in, for example, in GL 1.x to core functions in 2.x? For example, some of the names have changed. I mean, apart from adding ARB, some...
No, it's not that smart enough.
Okay.
It's basically for the extensions only.
Yeah, so if an extension got folded into the core, you can reference the symbol by the core name, and it'll pick the right implementation. But I mean, if you're specifying an extension name that's not valid anymore, it's not going to remap that for you. Is that what you're asking?
I mean, some functions for shaders change name when they enter
Sure.
into the core. As I'm not sure if you know, but other than that, they're the same. I mean, the command, the arguments are the same. So
yeah, so if the parameter list is the same, and so for example, create shader. Okay, so instead of GL create shader object arb, it's now GL create shader, but the parameter list is the same. So in that case, you should be able to call GL create shader, but based on detecting the implementation actually being a different version with the arb extension rather than the core version with the new thing, it should do the right thing there.
okay.
But it's not, you know, arbitrarily m by n, if you know what I mean. So we have just a few minutes left, and I want to make sure. Does anybody have anything else that they'd like to throw out on well, probably any of the compositors really, but certainly Compiz in particular.
It's about when do you think that getting Unity? You mentioned that there are a few functions there that you believe need to be changed, to be commented. I guess that has to do with launcher, the launcher part, right?
No. The only thing in Unity that should have to change is the plugin API for Compiz has changed. That's, like I said, that can almost be automated. It's such a straightforward change. And then where it hands Unity hands the Compiz context to Nuxt, so it has to be changed to the UGL there. So Unity itself is a very small amount of work once we have Nuxt going. So.
Yeah, about EGL, how much does that impact, do you think that would impact Nuxt? Nuxt is using the context that is created by Compiz, but
right.
If there's anything, I'm not sure we're using any GLX function inside of Nuxt by itself, except for initialization, but this is one you're using Nuxt in standalone.
Right.
Yeah.
I guess this will have to be replaced in order to make, sample tests, purely tests.
Yeah, I think I've actually already got that replaced. So, yeah, that shouldn't cause any troubles. And as far as kwin goes, when we were doing the demo last night, it noticeably had more impact on the system. So, have to figure out why that is. And it might just be because it was doing more things at the time, but it seemed a bit extreme. Like the OngoingGL ES demos that were running at the same time basically turned into a slideshow when kwin was running.
Okay, so we'll definitely add some performance analysis. Okay, I think that's it. Thanks everybody. Appreciate you coming, and you know, don't be shy. Please, you know, let us know if something occurs to you after the session as well. But thanks again.